Welcome. Let's understand the idea of exponential growth. So let's consider the following scenario. What if we have some value, which in this case, let's consider the value of 2, and we keep multiplying by some positive number that is greater than 1, which in this case, let me consider the value of 3. So let's get this 2 and let's multiply it times 3. Then our result is going to be 6. And we keep doing this. Let's get 6 and let's multiply times 3, which is going to give us 18. And we keep doing this. Now let's get this 18 and let's multiply times 3. Now we're going to get 54. And we continue doing this. Now let's try to think about, can we write down an equation that will follow this pattern? Well, let's take a look at one value at a time. The value that we started, which is the value of 2, is what we were given. We did not obtain this value by multiplying times 3. So what we can say is that the value of 2 is equivalent to 2 multiplying 3 0 times. And notice that the value of 6, it's a value that we obtain when we multiply 2 times 3 1 time. So this value of 6 can be represented as 2 times 3 1 time, raised to the first. And the value of 18, this is a value that we obtain when we get the value of 2 and we multiply 3 2 times. So we can say that 18 is equivalent to 2 times 3 2 times. The value of 54 is the value that we obtain when we got 2 and we multiply times 3 3 times. So we can say that 54 can be written as 2 times 3 3 times. The value 162 is the value that we obtain when we started with 2 and we multiplied times 3 4 times. So we can say that 162 can be written as 2 times 3 raised to the 4th. And 486, we obtained this value when we started with 2 and we multiplied times 3 1, 2, 3, 4, 5 times. So we can rewrite 486 times 2 times 3 5 times. And the next value is when we multiply times 3 6 times. So we can say that 1458 can be written as 2 times 3 raised to the second. Now, if we take a look at the results that we have written in blue, notice that there is a pattern between all of them. There is only one number that was changing from value to value, and that is the exponent that we have for the value of 3. We started with an exponent of 0, and then exponent of 1, then 2, 3, 4, 5, and 6. And everything else stays as it was. There was always a 2 that didn't have an exponent, and the 3 was the one that had the exponent. So if the exponent was what was changing, we can assign a variable to it. Then we can write down an equation for this scenario. We can write it as 2 times 3 raised to the x. And this is what we define as an exponential function, because notice that the variable is on the exponent. The unknown is the exponent. Now, what makes this an exponential growth? In other words, why were these numbers increasing in value? Well, they were increasing because we were multiplying by a number that was greater than 1. And that is what we define as the base of an exponential function. The value that we keep multiplying by will always be defined as the base of an exponential function. And the number that we started with, which is the number that didn't get multiplied times 2, is what we define as the starting value of an exponential function. So if we want to identify if we have an exponential growth function, the only thing that we need to look at is what is the value of my base? Because if that value is greater than 1, we will always have an exponential growth function. Now let's take a look at the graph of this exponential growth function. Well, one thing to notice is that this function, it's not a straight line. Notice that there's some curvature to it. But what about its behavior? Well, it is always increasing. But notice that as the value of x's are getting larger, the function, it is increasing faster. Another thing to notice is the location of the y-axis in this function. Notice that this location is when y is equivalent to 2. So if you want to think of coordinate points, we have a location at 0, 2. But notice one thing, the location of the y-intercept will always be the starting value in our exponential growth function. Within our function, the value that did not have an exponent will always be the y-intercept of our function. So now the value of 2, I'm not just going to call it the starting value. I'm actually going to call it the y-intercept. So now let's go to the next graph and let's see what happens when we keep increasing the value of the base of this exponential. So here we have our function when our base was equivalent to 3. Now what happens to the shape of this function as the base is increasing in value? Notice that the function, it's increasing faster, and the right-hand side of this function starting to look more like a vertical line. But let's go the other way around. Now, why do we decrease the value of our base? Now we have some kind of a curvature, which does not look like a vertical line on the right-hand side of our graph. But regardless, if we have a low value in the base, or if we have a high value in the base, our function, it is always increasing. This is the idea of an exponential growth function.
Hello. If you would like to continue learning about mathematics, you can check out the videos on the left.